let's see where we're at. Warm-up 114, very similar to what we've been doing with the other warm-ups, just extra practice. For number 1, I need a center and a radius. Center and radius. Center, Nick. 5, -3, and radius? 7. Hands if you got that. That is correct. Pass someone. Number 2.
I got 2 times 1 over x minus 1 plus 7.
2 times 1 over x minus 1 plus 7 is correct. Hands if you got that. Very good. Number 3. Pass someone. That? Y equals 7. Hands if you got that. That is correct. Number 4. Pass someone. Vince, x equals what? What's that? Oh, you should do that one? Okay. Help him out. Sebastian, what'd you get? X equals what? 4 units. That is correct. Therefore, tangent of angle A. Pass someone, Sebastian. Angle A, tangent. Tell your neighbor what tangent means. Oh, you got it? 4 over 3. That is correct. All right, agenda, copy this. Warm-up number 114, semester 2 concepts and skills. Now these, what time we got? We got about half an hour together, yeah? So it's going to go pretty quick, so stay with me. We're going to try and get through most, if not all, the study guide. We're probably going to be -3 problems or so. So we'll leave those for tomorrow, but hopefully we can finish as much as we can. So once again, warm-up number 14, semester 2 concepts and skills. Study your study guide tonight. So tonight you're going to have numbers 25 to, I believe, 31, something like that. So. And get a Cornell note. We're going to get it straight into the practice and your study guide in front of you. All right. So, last night's home plate. My goodness. Last night's home play, as I was saying, was problems number 20 to 24. So when you have some time, make sure you go to Canvas, turn that in. I'm going to give you till 3:25 today, just for the sake of keep on moving from where we're at. So, our objective for today, can master all semester 2 concepts and skills. So yesterday we finished off the section on rational functions. Right after that, throughout the year, I remember that we got to the next section, which was your favorite, exponentials and logs. So let's start with exponential functions. Exponential functions. Exponential functions. And that looked like this. G of x equals a times b x minus h, close parentheses, plus k. Now, according to that, tell your neighbor what h and k do. What does h and k do? Again. H goes what? Side to side, yes. K, up and down. However, K also serves as a second purpose now, known as the HA, which is our horizontal asymptote for our exponential function. Okay? Now, when we started with this, we had an exponential function that looked like this. Yes? And I remember I talked about two basic functions. The first one was f of x equals base 2 to the x, and the other one was f of x equals base 10 to the x. And I said, we're going to stick with those. And of course, I gave you some with base 3 or base 5, but those were the basics. So right now, if I want to look at this graph, looking at it through the lens of this one, here it goes. The parent function should look like this. Now, what are the points that I'm plotting here? Let me show you, right there and right there. This point is 0, 1. How did I get that? By substituting 0 of x right here. So what is 2 to the 0? 1. So 0 of x, 1 of y. Okay? How do I get this point, which is 1, 2? This is 1, 2. Okay, so let's see. If I substitute 1 into the x right here, what is 2 to the 1 power? 2. Okay. Then the next point over here would be at 2 what? Tell your neighbor, 2 what? What would be this value? Very good. 4. How do we get that? By substituting the 2 here for x, so it's 2 to the second. What is 2 to the second? 4. All right, good. You guys came prepared for this minimum thing. All right. So we have 3 points for this exponential function. So now I'm going to move this function. Oh, and by the way, bless you. By looking at it, does it have a constant here at the end? Is there anything there? No, so that means my HA is at y equals 0. That's why this graph, if I was to graph it this way, it wouldn't touch the x-axis. Okay, so now I want to move this according to a transformation, so watch. I'm going to write g of x equals base 2 x minus. So now watch. I'm using this one, look up. I'm using this one. But now I'm going to transform it according to this rule, yes? All right, so with that said, base 2, I'm going to move this one. I want it to move it 4 steps to the left, 3 steps up. 4 to the left, 3 up. 4 to the left, 3 up. 4 to the left, 3 up. Tell your neighbor what goes where. If I was to rewrite that equation, what do I substitute and where? 4 to the left, 3 up. What do I substitute and where? Four to the left, 3 up. All right, so let's get this party started. 4 to the left. Leo, what do I substitute to go to the left? Close, that's to go to the right. Negative. Okay, so negative 4. 4 to the left, yes? So instead of h, I substitute negative 4 because it's going to go 4 steps to the left. And 3 steps up, everyone. Where does that one go? Plus 3 at the end. Can we rewrite that now? Yes. G of x equals 2 x to the, 2 to the exponent of x plus 4, and then the constant of plus 3. So far so good, yes? All right. So this would move 4 to the left and 3 up, so it would be somewhere over here. But what if I wanted to do a different one? So I'm still looking at this one. I'm going to use green now. G of x equals 2 to the x minus. Let's move that, bless you, 5 steps to the right and 2 down. 5 steps to the right and 2 down. 5 steps to the right and 2 down. Tell your neighbor what goes where. Rewrite that, please. 5 to the right and 2 down. 5 right, 2 down. 5 right, 2 down. I write to down? Erica, what do I write and where? H is positive 5, yes. And then? Negative 2 on K. Hands, have you got that? That is correct. And that's basically what we do with transformations of exponentials. So with that said, get your study guide in front of you. Go to problem number 25. Problem number 25. Answer that question. Let me move this. So let's see, what do they give us? They give us, for number 25, f of x equals base 2 to the x. So they give us the parent function here. So what are my 3 points that I use? 0, 1, 1, 2, and 2, 4. I'm going to use those 3 points so I can move them around according to the new transformation, yes? So look at the new transformation that they want us to do. Tell your neighbor where we're going to move those 3 points to. Talk it over to your neighbor. Let them know. So when you get to these guys, this is what I want you to do. I want you in this graph to actually do the transformation yourself. So we're going to move it in which direction, everyone? 3 to the right and 4 down. So I'm going to start with this point. I'm going to go 3 to the right and 4 down. 1, 2, 3, 1, 2, 3, 4. This one. 1, 2, 3, 1, 2, 3, 4. This one, 1, 2, 3, 1, 2, 3, 4. And then I graph it. Then you match it to whatever looks like that. Tell your neighbor what you got for that one, please. Which one is the correct answer? Everyone? B is correct, yes. And that's how you work these, guys. Make sure, instead of looking through, because sometimes you're going to get confused, because there's going to be at least 2 that are going to be very similar. Just giving you a heads up, okay? All right. So, back to our notes. Go back to your Cornell notes. From there, from exponentials, I remember that we got to a new concept. And the new concept was logs. Ha, 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 ha. Ha, ha. Ha, ha, ha. And I remember I gave you something like this. X equals log base B A. All right? Tell your neighbor what the X stands for, the B stands for, and the A stands for. See if they remember. All right, looks like Maritza's got this. All right, Maritza's going to get us started. X stands for what, Maritza? X. Yes, exponent. That is correct. Exponents. Wow. Pretty good. How about B? B stands for what, Jaden? Base is correct. All right. Man, 2 out of 2. Here goes the funky one. What does this one stand for? Once again, tell your neighbor, see if they remember what A stands for before I call on someone. Now think about the warm-up that I've been giving you. What goes there? Think about it. Therefore, what does A stand for? Did I call him Leo already? Oh, Justin, what does A represent? What? What goes there, Kevin? What? We've been looking at the warm-up all week. What goes there? A what? A given number. Just a number. Look at the warm-up. Don't we have a log in the base? And there's a number right there. It's just a given number. Okay? Whew. And then we also talked about rewriting this because we needed to evaluate and simplify, and we needed to rewrite it as an exponential. An exponential. So, help your neighbor to rewrite this as an exponential. They should know by now. Let's see. Talk it with your neighbor. Rewrite that as an exponential. Justin, pass them one. Pablo. B to the x. Close. Once it becomes an exponential, there's no longer a log. So therefore, we just have A. That is correct, the given number. Yes? I really like that. I think I forgot, Mr. Q. So let me apply this to the warm-up. Warm-up was log base 2, 128. Okay. So when we got to these, I remember that the first thing we needed to do is change it into a what? Exponential, which means we need to set this equal to a variable, and we usually put a y. Is that correct? So can we rewrite this as an exponential? Yes. According to what we wrote, it's 2 to the y equals 128. So now we have 2 to the y. Let's see, we write the base 2, because now we have to write this in base 2. How do we know what exponent? Well, we'll start multiplying. What is 2 times 2? 4 times 2, 8 times 2, 32. 16, my bad, times 2. 32 times 2, 64 times 2, 128. So this is 7. And then at the end, once we have the same base, we just look at the exponent, so y equals 7. However, I remember I showed you guys a shortcut. Who remembers the shortcut? Oh, I remember the shortcut, Mr. Q. We can rewrite this like this. Log base 2, 128 and base 2 is 2 to the 7th. So in order to avoid doing all this, I said, if this is the same base as that, the correct answer is 7. Go straight to that. You guys remember that? Yes? All right. How are we doing? Okay? Okay? All right. Next, from there we introduce log functions. Log functions. And we got g of x equals a times log b, and then we have x minus h plus k. You guys remember that? Yeah? You're like, oh yes, Mr. Q. Once again, tell your neighbor what h and k do. Once again, up and down, side to side. Base is, the B or the base, it stretches it horizontal or compresses it horizontal. What does A do? Stretch or compress vertically. Stretch or compress vertically. Okay. We got it? Okay. So, let's see if we remember all that. Let's go to the study guide. Let's go to problem number 26. It reads, the graph of which is vertically stretched by a factor of 3. It's what? Vertically stretched by a factor of 3, translated 4 units to the right. Tell your neighbor which parameters, which are they talking about? Talk about your neighbor. Which parameters are they talking about? Don't look at the answers yet. I want you to think it out. Which parameters are they talking about? Vertical stretch, right 4 units. All right, so vertical stretch, what parameter are they talking about? A is correct, okay. How about units to the right? H, okay. But now we have a dilemma. We have a log and we have an exponential option. So think about it. We talked about exponentials. I gave you 2 to the x or 10 to the x. Logs, we did a times log base b, x minus h plus k, okay. So by looking at it, which one is being multiplied by 3 and moved to the right 4 units? Tell your neighbor which one do you think would be our option? All right, let's start with C. Would it be C? No, because this one would move it to the left, okay? So not that one. Let's look at D. Will this one move it to the right? It looks like it, but does this multiplier go there? No, it usually goes where? Right there, so that's not the option. Okay, so it has to be between those two. Tell your neighbor which one and why. Which one and why? Correct answer is B. That is correct, because that goes before the log. Okay? All right. Let's keep rolling. Let's go to this was number what? 26. Let's go to 27. All right. So we have log base 4, 1/16. Before you do that one, I remember when we got to these, I said, all right, guys, write your utensils down, and I did log base 2, 1/4. I need to rewrite this in the same base. Log base 2, 1, 4 is 2 to the what? Second. But it's in fraction form. We can have it in fraction form. So what do? Reciprocal and reciprocal. So this is log base 2, 2 to the what? -2. Once we do the reciprocal, it changes the sign of the exponent. Now, is this a base 2? Yes. So therefore, if this is the same as this, what is the answer? -2. Okay. With that said, do that one. We have log base 4, 1/16. I'll give you some time. Hurry up, please. Go. All right. Tell me what to do for this one, Mel. Go. Log base 4, what do I write? 1 over what? 4 squared. So this is log base 4 and then what? Four to the -2. So correct answer for this one is C. Hands if you got C. That is correct. How are we doing? Yes? Okay. All right, let's move on. That was number 26, was it? 27. Let's go to 28. Do that one by yourself. Very similar to the one we just did. We got log base 4, and now we need to write 64 in base 4. Yes? I'll give you some time for that. Go. Four to the what gives us 64 now. 4 to the to the fourth. Let's see. 4 times 4 is 16. 4 times 4 is 16. So that's 4 of them. 16 times 16 is 256. 4 to the what, Umberto? How about the other Umberto? To the third, that is correct. 4 times 4 is 16. Times 4, that's 64. Therefore, correct answer is B. So once again, guys, the easiest way of doing these, just write log, and then look at the base. Take this number, write the same base, and then start with your fingers multiplying times that number by itself. What is 4 times 4? 16, okay. What is 16 times 4? 16 times 4, 64, okay. So that's 3 times. That's how you do those, okay? All right, so far, logs, how are we doing from 1 to 5? Coming back, some of you, yes? All right. Next, number 29, yes? Here we go. So, before I do this one, or we do this one, log base 3 to the 27 minus log base 3 to the, give me a number? 3. All right. So look up. Whenever we got to these, now we're looking at subtraction. But when we have the same bases, we can write it as 1 log with the same base. And we just take these numbers, and instead of subtracting, we're going to do this. We're going to divide. Whenever you see subtraction of logs, what do? Divide. So what if we have addition? You multiply those two numbers. So therefore, what is 27 divided by 3? Log base 3, and it gives us 9. Can we write the 9 in base 3? Yeah, this is log 3, 3 to the what? To the second. So the answer for this is 2. With that said, do this one by yourself. See how you do with that. Two to the what gives us 64? Oh, my bad. My bad. Do they have the same base? Yes, so it's log base 2. And what happens to those two numbers? 64 divided by 4. Is that correct? So this becomes log base 2. What is 64 divided by 4? 16. Log base 2. How do we write 16 in base 2? 2 times 2, 4 times 2, 8 times 2, 16. So that's to the 4th. So what is the answer? Same base. Answer is 4. Do the next one by yourself. See if you can do the next one by yourself. This is number what? What is it? 30. Okay. So we got log base 3, so we write it as 1, log base 3. What happens to those numbers now that we're adding, guys? Multiply. 6 times 4.5. So this becomes log base 3. 6 times 4.5 is 27. What is 27 in base 3? 3 to the what? To the what? To the 3rd power, yes. So therefore the answer is B. For subtraction, we divide the two numbers. For addition, we multiply. And the last one for today, number 31, log base 3. Before anything, look up. How do we write 27 in base 3? 3 to the what? 3 to the 3rd, okay? But what was already there in the exponent of the 27? Times negative 3 in the exponents. Therefore, this becomes log base 3, 3 to the what? 3 times negative 3 is negative 9. Correct answer for this one is B. So, tonight's home plate, numbers 25 through 31 only. So your home plate, guys. See you guys tomorrow. Bye.